Bright Tuty. Every student matters.
Now let's move on to the second part, chemical equations. Now what is a chemical equation? All of these are chemical equations. Chemical equation is basically a representation of a chemical reaction having reactants and the products in form of symbols and the molecular structure. So chemical equation, like this is an example of chemical equation. It has four components. First is the number of molecules. It should tell how many molecules of each atom, each compound are contributing to forming of the new compound. Second is the heat exchange. A chemical equation should tell if heat is being absorbed or heat is being released and where is it coming from. Like in this reaction, we are telling that the sunlight is being absorbed. This is a reaction of photosynthesis. So as you can see, sunlight is being absorbed. 6 molecules of carbon dioxide, 12 molecules of water are reacting to form the food in the plant. The third is symbols. Now in chemical equation, there is a strict rule of what symbols can we use. This is a universally accepted pattern of what everything means. So this means calcium everywhere, universally in the world. So we cannot say something like oxygen. We cannot write like this in a chemical equation. That will be wrong. We cannot write like quicklime. We cannot use the common day-to-day words like baking soda, quicklime. Those words are not allowed in a chemical equation. It has to be the symbols which are universally accepted for every element and molecule. Now moving on to the fourth component of a chemical equation, that is the physical state. Every atom is reacting in a particular state. It is either solid, liquid or gaseous. Now physical state is very important because sometimes when two solids are kept together, they might not react. But when they are dissolved in water, when they are in an aqueous state, then they do react. So it is important to understand what is the physical state of the reactants and the product. It is denoted by these symbols. Put in a bracket at the end of every element. L suggests liquid, S for solid, G for gas. Aqueous means a solid which is dissolved in water. So it is an aqueous solution of that given compound. So chemical equation is a representation of the chemical reactions only, but in form of reactants and products. Reactants always on the left hand side, products always on the right hand side with an arrow in between, and it represents the number of molecules, the heat exchange, the symbols and the physical state of the elements. Now this is an ideal chemical equation because it is satisfying all these components. Let's see, the number of molecules are mentioned everywhere. The heat exchange is mentioned, that sunlight is being absorbed. The symbols are given for all the elements. I'm not writing carbon dioxide or I'm not writing water here. And the physical state of every element is mentioned here, like aqueous, liquid, aqueous, gas and liquid. So all this indicates a perfect chemical equation. Now you must be wondering, why is it that we cannot just write CO2? Why do we have to write 6 molecules? Now with that we'll come to the next topic, that is balancing of a chemical equation. Balancing of a chemical equation means that the number of atoms on each side of the reactant or the product side of every element should be equal. So there should be equal number of atoms of every element on the reactant and on the product side. Look at this equation. There's one calcium element here, one calcium molecule and one calcium. So calcium is balanced. Oxygen 1 here, so total 2 here. Oxygen is 2. And here also there are 2. So it is oxygen is also again balanced. Hydrogen are 2 here and 2 there, again balanced. So this is a balanced chemical equation, which means that the number of atoms of each element on the reactant sides total is equal to the number of elements on the product side. Now why do we need to do that? Why do we need to balance a chemical equation? We need to balance a chemical equation because the law of conservation of mass suggests that matter can neither be created or neither be destroyed. So if there is an atom extra here, that means somehow in the reaction a new matter is created, which is not possible. It can also be the reverse. If there's extra atoms here, which means something was here but then it was destroyed. Matter cannot be destroyed and matter cannot be created. So to satisfy the law of conservation of mass, so that no new matter is neither created or destroyed, we follow the balancing of equation rules. Now to balance the equation, before getting to that, we will understand different ways in which numbers are put across so that we can understand how to balance an equation properly. Now here you can see that this 2 is part of the formula. So when I'm saying H2O and there are supposedly extra hydrogen atoms or less hydrogen atoms, I cannot change the composition of the molecule. If I make H2O into something like H3O, that will be wrong, because now it will not be water anymore, it will lose its properties. So we cannot change the properties of a matter, so we cannot change what is inside the molecule. But we can have more than one molecules. So 2 here, this red 2 indicates that there are 2 molecules of water, which is a possibility. We can have 2 molecules of water in a reaction. The 2 here indicates that since it is outside a bracket, it implies that there are 2 molecules of hydrogen and 2 atoms of oxygen. 2 atoms of hydrogen and 2 atoms of oxygen. So when something is outside the bracket, it goes for all the atoms within it. So we've understood so far that a chemical equation represents a reaction, and that equation needs to be balanced. No new matter can be created in an equation, and that is where we have to balance it out. For balancing, we cannot change the molecular composition, but we can add the number of molecules. So let's do some examples and understand how to balance a chemical equation. Here's a chemical equation of lead oxide reacting with carbon, forming lead and carbon dioxide. So we will draw this chart every time we have to balance. We'll make a column for element, one for LHS and one for RHS. So the elements that we have are lead, we have oxygen, and we have carbon. How many lead molecules on this side? Just 1. On this side, 1. Now how many oxygen here? There's 1 here. But here there are 2. Carbon 1 here and 1 here. So everything else is balanced except the oxygen. We cannot have 1 oxygen making 2 oxygens. That's not possible. So what we will do is, we will add a 2 here, and that will make the oxygen atoms 2. Now when we add 2 here, this becomes 2, but this also becomes 2. Now we have 2 lead elements here. So to balance this out, we put another 2 here. Now let's count. Lead, 1, 2 here, 2 here. Oxygen, 2 here, 2 there. Carbon 1, carbon 1. So this equation is balanced out. Now let's try with another example. We have ferrous sulfate, and we break it down in the presence of heat, and it breaks to form Fe2O3, SO2 and SO3. Now the number of Fe elements, here it's only 1. Here it's 2. S, 1 here, 2 here. O, 4, and here 3, 4, 5, 6, 7, 8. Right, so there are less atoms here and there are more atoms here. What I can do is, if I have to make, it's always better to start with the bigger number. So we see the bigger number here is oxygen, which has 4 atoms, and we want it to be 8 to balance it out. So to make it into 8, we multiply it by 2. 2 4s are 8, and we get 8 oxygen atoms here. Now let's see what will happen to all the other elements. There was 1 ferrous initially, but now there are 2. There was 1 sulfur, but now there are 2. And there were 4 oxygens, and now there are 8. So again, as you can see, it's balanced. 2, 2, 2, 2, 8, 8. So all the atoms are balanced. The number of iron is same. The number of sulfur is same. 2 here, 2 here. Number of oxygen 8 here and 8 there. So the equation is balanced. So this is how you balance an equation. You start with the number which has the maximum number of atoms and you go out seeing how it affects other elements and then balance it out to have equal atoms of every element on each side. Let's do another example. We have iron reacting with water to form iron oxide and releasing hydrogen gas. We have 1 iron in the reactant side but 3 here. We have 2 hydrogen here and 2 hydrogen there. We have 1 oxygen and we have 4. So as I said before that oxygen is the one which has the maximum number of imbalance, so we will start with balancing out the oxygen first. There we have to make it 4 times more here, so I will put a 4 here. When I put the 4 here, the hydrogen also becomes 4 times more, so I have to balance it out here. Now the hydrogen is 4 into 2, 8 here and 4 into 2, 8 here. The hydrogen is balanced out. Oxygen is also balanced out. There are 4 here and 4 there. But iron, there are 3 and there is 1. So I put a 3 here and now the equation is balanced out. We can check how many iron here, 3 and 3 on the other side. How many hydrogen, 8 and 8 on the other side. Same goes for oxygen, 4 here and 4 there. So now the equation is balanced. Let's do this last example, it is very simple. We are reacting hydrochloric acid with iron to form FeCl2 and hydrogen gas. The 3 elements here are Fe, H and Cl. Now for H there is 1 here and 2 there. For Fe there is 1, 1. For Cl there is 1 here and 2 there, right? So if I put a 2 here, there will be twice hydrogen atoms and twice chlorine atoms, which will balance out the equation. Now you can see there's a 2H here, 2H there, 2 chlorine here, 2 chlorine there, 1 iron and 1 iron. So all these are examples of balancing out an equation. Just to go through the first part again, we understood what are chemical reactions. We understood the basic properties of features which tell us that a chemical reaction has occurred. We went on to understand what are chemical equations and what are the main components that should be included, and then we understood how to balance it. Thank you.